Welcome back to ABT. We're going to take a look at some equipment load calculations using a psychometric algorithm. And so we've created this folder here on a desktop, and we have an intro form called HVACR Training Center 0001. We have a load calc form of air handler 1, chilled water comfort cooling. We also have air handler 2, chill water comfort cooling, air handler 3, chill water comfort cooling. We also have a load calc for same project number or job number 0001, MUA 2C, test number 1, the preheat coil, and MUA 2C, test 2, the preheat coil. We also have some mixed air calculations, and these are the text files. These are the XML files. These are the files that the software we use to open, and these are the text file that we can actually view. And we'll take a look at those in a minute. So we also have a mixed air for MAU2C that feeds all these air handler coils. And this is the chilled water coil test. So let's take a look at a diagram. In this case, we have makeup air unit number 2C. We're bringing in 100% outside air, going through some pleated box filters, and then we have a dehumidification coil, preheat coil, chilled water coil, then a reheat coil, then a humidifier with some mesh. Then we have a fan, supply fan, some HEPA filters, and we feed air handler 1, air handler 2, and air handler 3. We also have air coming in from return from the zone or the lab, and we're feeding into the lab. So let's go ahead and take a look at our report here. In this scenario, we have the HVACR Training Center, 2980 South Rainbow Boulevard, Las Vegas, Nevada, 89146. Our first condition is MUA2C preheat coil. That would be this coil right here. So MUA2C preheat coil, supply air temperature. So coming off this preheat coil, we got a supply air temperature of 68 degrees. Our outside air temperature is 55. Our wet bulb is 45. And our elevation is 450, and we're delivering 25,000 CFM. So in our first test, we want to know how many BTUs of sensible heat transfer the preheat coil is delivering in BTUs per hour. In this first test, we also want to know what the GPM flow through the preheat coil, so we want to know the actual flow through the coil. If our inlet temperature is 180 degrees and our outlet is 150 degrees. In test number 2, we want to know how many pounds per hour for the humidifier to deliver 65% RH. So let's go ahead and take a look at that scenario. So the first thing we're going to do is we know we have a file in our system called HVACR Training Center 0001. And this is a good time to kind of discuss how the file structure works. We don't have an HVACR Training Center on our desktop. As you can see, our actual file is pointing towards our desktop. We do have one in this folder here, so we're going to go ahead and right click that and go copy, and we're going to go ahead and paste it here. So now when we go to try to open up this intro form for HVACR Training Center 0001, let's spell training center right. Now we can open up that file. So let's go ahead and open up our next file, which is going to be the 0001 MUA2C test number 1 preheat coil. And whether I type lowercase or uppercase, either one is going to work. And this is for the preheat coil. So now we have our parameters here. We have our preheat coil is 68 degrees. So we have 68 degrees. We have entering air 55 at 45 wet bulb, 55 at 45, and an elevation of 450. If you weren't sure what our elevation is, we can always go to this link here. Type in your address, 95377, or zip, city, whatever, and it'll give you your actual elevation level. So now this was an example, 450 feet above sea level, and then we have our humidity ratio, grains of moisture, relative humidity, specific heat, enthalpy, specific volume, dew point in pounds, and pressure per cubic feet. So now our outlet temperature is going to be 68 degrees. Well, we know that if we're just increasing or decreasing in sensible heat, we're not changing our grains. It's a straight line. So what we want to do is we want to go ahead and make sure that we match our grains, and we can do that by just changing the number to whatever you want. We want to make sure though that as we calc these values out, in this case the tool is very sensitive, so I'm at 2868 and this is 2866. Let's go ahead and add 1, and it carries it over to the heating side. So one of the main rules is when you're entering this data, you don't want to carry past the hundreds. Even though the other values will go past the hundreds, and you're entering data, try to keep your values under hundreds. Okay, so the other thing we want to do is this is 25,000 CFM, and this is a hot water coil, so we would check the hot water coil. We have an entering of 180, outlet of 150, and here's the 500 times GPM times delta T is going to be our BTUs per hour. So let's go ahead and try and do that. So if we said 500 times 23.4 and delta T of 30 times 30, and because we're doing sensible heat, we're not adding any moisture, this is the number we're using, the 35.1. The system is so accurate that it will pick up numbers past the hundreds, and we don't have any tools at this point that are typically plus or minus 0.5% is a very expensive tool. Most sensors are going to be plus or minus 2%. So in this case, all that matches up. So the questions that we have is how many BTU sensible heat transfer? That would be 351,000 BTUs. How many GPM is flowing through the preheat coil if the inlet temperature is 180 and the outlet pipe temperature is 150? That would be 23.4 GPM. And test number 2. How many pounds per hour must the humidifier deliver to output 65% RH? Let's go ahead and bring up test number 2. And in test number 2, we got 55, 45, 68, degrees. And our relative humidity is 63. And this part of it I did not complete, so let's go ahead and complete this now. So we're trying to get to 65% RH. Let's go ahead and take this value here, and we're looking for 65% RH. And we'll try 61, and that takes us to 67. So we're going to go 0.1, 65.3. So we're going to go, and we only want to carry to 100th. So 64.9, 65. And we're looking at RH, not grains, so that could easily be done. Let's go ahead and try 61. We're at 67.08. And we'll go to 63. 63. 64. 65.04. And in this case I wouldn't add a 1 because I'm actually over 65. So we're only going to carry this one out to the tenths. So now we have an inlet, outlet, and now we have our grains converted into pounds per hour and gallons per hour, added or removed. So in this case, this machine would have to output about almost 600 pounds per hour to be able to maintain the 65% RH under this condition. We're going to go ahead and we would copy that, and we could actually paste it into there. We can also do this. For the first test, we're going to go ahead and save the text, save the file. And let's go back to test number 1. Getting a little ahead of myself. From the intro form, company name doesn't apply, and an email. Alright, so now we have all our data entered there. So let's continue on. So the next test, we're saying that MUA2C is delivering 60 degree at 48 RH to air handlers 1, 2, and 3. Air handler 1 supplier temperature 61 degrees, and the return air is 72 at 40% RH. Our elevation is the same, 450. And these machines deliver 15,000 CFM. Okay, what's a mixed air temperature? Wet bulb, relative humidity, grains moisture. Well, this is going to be a load calculation and a mixed air, because the next one says, what is a supply air wet bulb temperature? Grades of moisture, relative humidity. So let's go ahead and start with the next set of files, which are going to be our air handler 1 chill water coil comfort cooling. That's going to be our load calculation, and our mixed air of MUA 2C and air handler 1 for the chilled water coil test. So for the load calc, it's just called 001 AHU1. 001 AHU1. Okay, so here's our after our mixed air is completed. So let's take a look at our mixed air. So that would be MUA 2C dash AHU1, same job number, but it's just called chill water coil. We could change the name to whatever we want, but in that case, these two files go together. So let's take a look at our conditions. The two mixed airs are stream 1 coming from MUA2C would be 68 at 40% RH. So here's 68 and here's 48% RH. Now our elevation is 450 still. Our CFM is 15,000 CFM. Okay, so air handler 1, the supply air temperature is 61 degrees, but for our mixed air, our return air is 72 at 40%. And as you can see, we have 72 degrees dry bulb, and we're about 40.05%. So as we go through and calc these buttons out, the mixed air will enter a certain amount of data. So not all of these get populated at once. To be able to fine-tune this, what we need to do is we need to match our grains, because at this point all we're doing is trying to match the grains, and as we increase or decrease this number, you can see our numbers will change. Once we match our grains and we're happy with the number, and let's say we go back to 9, and that takes us to 45, takes us to 48.48, but at 5 takes us over 51. So let's take it back to 49. At that point we hit the OK, and that populates this section with the remaining values that need to be populated. After that happens, then we save the text, save the file, and now we want to go ahead and push this data that we have, our mixed air calculation, and we want to go ahead and bring it into this value here. So we're going to go ahead and copy this, because you'll see what happens as we go to the air handler inlet for cooling, and we push this data up to the next file. You can see it cleared out our data here. So now we want to go back and say our supply air temperature is 61 degrees. At this point there is no transfer in grain, so our grain is going to stay the same. So we're going to go ahead and say 61, 61, and that's why I kept that value. So we want to match our grains, and we got 48.48, 48.47. To me that's close enough. This is a 15,000 CFM air handler. We hit our load calc. This is a chilled water coil. So at this point we would only be flowing 32.4 GPM through this chilled water coil, and our BTU transfer would be about 10.7 or 10.8
Tons.
and this is a 13.5 ton air handler. So in this case we would say, what's the mixed air temperature? Well, our mixed air temperature, we still have it, it's right here, and we can say 69. Oh, I missed a step. Let's go back. This mixed air temperature, how do I know what my cubic feet of air is between these two values? Well, what I want to do is I want to take this mixed air calculator and say, we know the outlet of this machine is 15,000 CFM. Our outside air, or in this case it's going to be our makeup air, is 68 degrees. Our return air is 72 degrees. And our mixed air is 68.99. In this case, when you're using this mixed air tool, you want to carry it to the ones. So let's go ahead and carry this to 69. And so that gives us 11,250 coming from the makeup air unit, 3,750. So 75% of this air is coming from the makeup air unit. So now that we've pushed this data up already, we go to our load form. We've made our adjustment. We've got 61 degrees at a relative humidity at 60. And we want our relative humidity to be what? Now, there's no specification of what we want it to be, so we need to calculate what our mixed air temperature is at this point. So our mixed air temperature is this. Let's go ahead and copy that. Our wet bulb temperature would be our RH would be and we can say make that a 3 since this is a 0.5, and our grains per pound, that's our grains per pound. Okay, what is a supply air wet bulb temperature? Well, our supply air wet bulb temperature is what is our RH? We're going to make that a 8 because it's 6, 7, 8, so we'll make that an 8. And our grains per pound, how many GPM is flowing through the chilled water coil? If the inlet pipe is 45 and the outlet pipe is 53. 45 and 53, when we hit our load calc, we came up with this number. And in this case, we could actually say, we're going to make that 0.4 GPM. How much CFM is return air and how much is makeup air? Well, this is our return air. This is our makeup air. What is a sensible heat load calc, latent heat load calc, and total heat load calc? And SHR. Well, the sensible heat ratio would be divided by the latent. Well, we can still check that just to see what that means. The latent divided by sensible, right? So let's go back to our, this is our mixed air. Let's go back to our load. So here's our sensible. Our latent. So if we want to know what our sensible heat ratio is based on this, we can go take a calculator. 12,9514 divided by 13,1598. So it's 98%. 98%. Okay, so the next, so this one is actually done, so we could actually save the text, save it to XML, and go back to our mixed air so we can overwrite the existing. In this case, this would be air handler 2. And so let's go ahead and go to air handler 2. And let's go to our mixed air for air handler 2. So the file names pretty much stayed the same. You want to try to keep the file names the same as you can if you're doing multiple tests. It's saying that our supplier, by the way, our makeup air unit is still the same, 6848. So let's take a look at the mixed air for air handler number 2. Our return air is 7442. So 74, 42, 68, 48. Okay, so we have all our values in. And again, we have 68.9, or in this case, we would say 69. So let's take a look at our mixed air temperature. And we'll say this machine also, for air handler 2, is each one of them, we know what the outlet CFM is because these are rated. We've measured them, and we've got 15,000, 15,000, 15,000. In this very first one, we've already identified all our values. We're going to identify our mixed air from air handler 2, how many tons, how many GPM we're flowing through this pipe for the chilled water coil. So we have 68 at 48, 72 at 42. What is our mixed air temperature? And what else are we looking for? We're looking for the mixed air temperature, the wet bulb, relative humidity, grains of moisture. We want to know what we have coming in here. And then we want to know what is our supply wet bulb, RH, and grains of moisture that we're delivering into this lab. How many GPM are flowing through this coil? How much is return air, and how much is makeup air? What is the sensible heat load, latent heat load, and total heat load? The sensible heat ratio. So let's do these calculations. So we're going to go ahead and bring in our mixed air. And we know we have 15,000 CFM. We have 68 degrees, 74 degrees, and 69 degrees. That gives us 12,500 and 2,500 coming in from return. So 83% of this is makeup air. And makeup air actually is coming from outside air. Do MUA2C. So now what we want to do is we want to go ahead and say, what is our mixed air temperature, wet bulb, relative humidity, and grains of moisture. So as we go through and do these calcs, 2, 3, we calc this out and we say, okay, we're pushing this. Grains of moisture here is the same again, and 49.65, 49.63. If I go up to 0.8, 49.67, I'm over. So let's bring that to a 7. And we'll say 6.3. As we push this over, we would actually load this data to our air handler number 2, which is there. So let's go ahead and go back. We're going to go ahead and copy this again, because I'm going to lose it when I push the data up. We're also going to air handler inlet for cooling. We load the data. Here's our load calc. We know we're 61. We're saving that wet bulb from the last recorded data, so we're not having to play with the numbers very much here. And we got 49.63, 49.62. If I went to a 6, I would be over, so we're going to go 5.9. We're going to say 15,000 CFM. And now we have our data. We've got our chilled water. We have our GPM at 36.98, or we could say 37 at that point. So let's go ahead and add our data into here. What's the mixed air temperature? Well, our mixed air temperature is, or we could say 69, either way, right? So there's our mixed air temperature, our wet bulb, our RH, our grains of moisture, what is a supplier wet bulb RH in grains? Well, based on these conditions we said, our wet bulb is this. What is our RH? What is our grains? How many GPM is flowing through the chilled water coil if the inlet pipe is 45 and 52? How much CFM is return air and how much is makeup air? Oh. So return air what is a sensible heat load calc? Latent heat, total heat, and SHR. So let's go back to the air handler. Load calc. There it is. The latent. And we can say 131482 129437 divided by 131482. It's about 98%, right? So we just go 98. Cool. So now we have all that data. We're going to save the text, save the file. We'll go ahead and take our mixed error. We'll save that to text, save that to file. And then let's go ahead and take a look at the very last one. We have a supplier temperature, same thing, 61 degrees. Our return in this case is going to be 70 at 38% RH. What is the elevation is for 450 still, and the CFM is still rated the same at 15,000 CFM. And then we want to know the mixed air temperature, wet bulb, relative humidity, grains, and what is the supplier, wet bulb, relative humidity, and grains. How many GPMs flowing through the chill water pipe? If the inlet pipe is 45 degrees and the outlet is 54. So we'll go ahead and go to air handler 3. We'll go to mixed air. Okay, so now we're on air handler 3. We're reading air handler 3. Mixed air for 3. We're reading the mixed air for 3. Okay, so you know that you're reading because every time you hit the read from XML, you'll get this message box that tells you where the file was read from. So, air handler 3, the makeup unit is still the same, 68 degrees at 48% RH. In this case, our return is coming in at 70 at 38. So here we go. We got 70 degrees at 38% RH. We want to figure out our CFM. Let's do that first. So we're going to go mixed air percent. And if it's already down here and open, nothing populates. So you got to go down and grab it. 15,000 CFM, 68, 70. And we're going to say 69 again because we want to round off. And then we got 7,500, 7,500 for both. Okay, so that's where we get those numbers from. We're going to calc all the buttons, and then we want to fine tune here and match our grains. So 4529, 4529, 291. Close enough. Calc, push it over. And then let's go to the load calc for air handler 3. We're going to copy that again so I don't have to try to fine tune that. We're going to push this up to the inlet of the coil. So we push the data up. We go to 61. We'll paste our data. And so now we have a grains. In this case, there's no dehumidification happening at the chill water coils. They're removing sensible heat, not latent heat. In this case, we want to match our grains. We got 29.145, 29.100. Close enough for me, so we're going to go ahead and say 15,000 CFM. The load calc, our chill water coil is delivering 28.79 if our inlet pipe is 45 and 54. So let's go ahead and finish the rest of this. What is our mixed air temperature? Our mixed air temperature is what's our wet bulb? And what's RH? What's our grains? So what is our supply air wet bulb, relative humidity in grains? Grains per pound. How many gallons per minute is flowing through the chill water coil if the inlet is 45 and 54? How many CFM is returned and how much is makeup air? Well, we said 7,500, right? So let's just type that in. What is a sensible heat load, latent heat load, total heat load? Okay, so let's go back to there. Get all that information. And we'll just keep these rounded off, that'll be better. And then we'll go ahead and try to figure this one out again. So we're going to say, well, 12,9583 divided by 13,1157. 13,1157. About 98% or 99%. So we can say 99%. We'll go ahead and save that. So then, now we have all this data that we can look at, but the nice thing about it is when we generated the text files, this is the text files that was generated, and we could actually now have a report that we could actually send someone. We'll save that. Then we got a load calc. This one is for the training center, air handler 1, model number, serial number, tag, chill water, comfort cooling, 13 ton CFM, series of labs, vintage. So we got some equipment conditions. We have our site conditions, elevation. We have all our entering air, psychrometric conditions, leaving air, HTO added or removed, chill water coil, DPM, calculated tons, and BTUs. We have that for all our units. We have the preheat coil data as well. Calculated GPM and BTUs. And then we have our mixed air calculations with all the data that we need. So this gives you unlimited power to do a massive amount of psychrometric algorithm calculations, load calculations, and equipment data. There's another tool that's going to be coming out. It's going to be a full system analysis. This tool basically is just a load side that goes along with the other options that you have with your air balance tools, which is all your design stuff, K factor, VAV, duct design. Thanks for watching. I hope you like this video.